You know the story? It's the late 1600s. An apple falls from a tree in an English orchard. A man sitting nearby watches it happen. Now, the legend says Isaac Newton discovered gravity in that moment, but that's not quite true. Humanity already knew things fell down. Newton's genius wasn't observing that the apple fell. It was in asking a very specific question. Why? And more importantly, does the exact same why that pulled this apple to the dirt also pull the moon in its orbit around the Earth? Welcome to the podcast. I am your host, and I am a physicist, which means fundamentally, I am in the business of asking why. If you strip away the massive particle colliders, the chalkboard's covered in equations. And the satellite array's physics is really just a formalized version of a toddler's favorite game. You know, the endless chain of whys. Why is the sky blue? Because molecules in the air scatter sunlight. Why do they scatter sunlight? Because of the wavelength of blue light. Why does light have wavelengths? Because it's an electromagnetic wave. If you are a parent, you know, this game ends in exhaustion. You eventually throw your hands up and say, because I said so, or because that's just how it is. But if you are a scientist, where does the game end? How many whys can we pursue before the universe itself finally says, because that's just how it is? Tonight, we are going to explore a deeply provocative idea. We are going to look at the bedrock of reality, and we are going to ask whether science has a double standard when it comes to the greatest mystery of all. The human mind, let's go back to that falling apple. If we ask, why did the apple fall? Newton gives us an answer, gravity. He even gave us the mathematical description of it. Mass attracts mass. But if you play the toddler game and ask Newton, okay, but why does mass attract mass? Newton did not have an answer. In fact, he famously wrote, I feign no hypotheses, which is 17th century Latin scholars speak for. I have no idea, and I'm not going to guess. Newton hit his bedrock. He hit a dead end. It took over 200 years for someone to come along and drill deeper. Enter Albert Einstein. Einstein looks at the apple and says, mass attracts mass because mass bends space-time. He completely reimagined the universe. Space and time are not an empty stage where things happen. They are a flexible four-dimensional fabric. A planet or a star rests on this fabric like a bowling ball on a trampoline, creating a dip. The apple falls because it's rolling down the curve in the trampoline. Brilliant. Beautiful. But let's play the game again. Why does mass bend space-time right now in physics departments all over the world? People are trying to answer that. They are working on string theory and quantum gravity and searching for theoretical particles called gravitons. But let's imagine a future where we find the answer. Let's say we discover that space-time is actually made of tiny, vibrating loops of quantum entanglement. What happens when we ask, why do quantum loops vibrate? Eventually, we have to stop. Every branch of physics eventually hits what philosophers call a brute fact. A brute fact is a foundational law of the universe that cannot be explained by anything deeper. It doesn't rest on another turtle. It's the bottom turtle. Take the speed of light. In a vacuum, light travels at roughly 300,000 kilometers every second. It is exactly the same speed for all observers, no matter how fast they are moving. If you ask a physicist why light moves at exactly that speed, we shrug. We say, because that is the fundamental speed limit of causality in our universe. We do not demand a deeper mechanism. We accept the brute fact. We use it to build lasers, launch satellites, and understand the Big Bang. In physics, we are incredibly comfortable with bedrock. Now, let's leave the realm of astrophysics and journey into an entirely different frontier. The 3 pounds of wet, electrified sponge inside your skull. The study of consciousness. Let's say you pick up that apple Newton was looking at, you bite into it, it's crisp, sweet, and bright, vibrant red. Neuroscientists can put you in a functional MRI machine while you look at that apple. They can trace the exact photons hitting your retina. They can watch the electrical signals travel down your optic nerve. They can pinpoint the exact network of neurons lighting up in your visual cortex. Imagine it's the year 2100. neuroscience has mapped everything. They can say with 100% mathematical certainty when this exact arrangement of 86 billion neurons fires in this exact sequence, at this exact frequency, that corresponds to seeing the color red. They have found the equation, the biological equivalent of E equals mc squared. But if you look at the landscape of neuroscience and philosophy today, people argue that this will not be enough. Even if we map every single synapse, the philosophers will still stand up and ask, why? Why does that specific pattern of neuronal firing correspond to the subjective, internal, undeniable feeling of the quote-unquote redness of red? Why doesn't it feel like blue? Or why does it feel like anything at all? Are we just biological robots, flesh and blood computers, processing the light data in the dark without any inner movie playing in our minds? This is what the philosopher David Chalmers famously called the hard problem of consciousness. The easy problems, which are still incredibly hard, are about mechanics. How does the brain process visuals? How does it control the tongue to speak? We can solve those. But the hard problem is the gap between the physical mechanism and the subjective experience. And this is where I, putting on my physicist hat, start to get a little bit defensive, because as a physicist, I look at this debate and I see what looks like a glaring double standard. Think about it. When Einstein says mass bends space-time, we all applaud, give him a Nobel Prize, and accept it as a foundational law. Nobody says, wait, Einstein, there is an explanatory gap here. Why does mass bending space-time result in the quote-unquote fallingness of the apple? We just accept that mass equals gravity brute fact. But when the neuroscientist says this neural firing equals the redness of red, society rejects it. We say, no, that's not enough. You have not explained the magic of the feeling. We refuse to let consciousness be a brute fact. We demand that neuroscience explain the why to a degree of satisfaction that we never demand from physics. Why the double standard? Why is physics allowed to hit bedrock, but the science of the mind is forced to keep digging with a broken shovel? To answer this, we have to look at what physics actually is. And to do that, I want to introduce you to a profound insight by the philosopher Bertrand Russell. Russell noticed something about my field of physics that is a little embarrassing to admit. It's a secret that hides in plain sight. Physics is entirely hollow. What I mean is, physics only ever tells us what the universe does. It tells us how things relate to other things. Mass is defined by how it resists acceleration and attracts other mass. An electron is defined by its charge and its spin, which are just mathematical ways of describing how it pushes, pulls, and interacts with other particles. Physics is a catalog of behaviors. It is an intricate, gorgeous, mathematically perfect map of the scaffolding of reality. But it is totally silent on what that scaffolding is made of. Imagine you are watching a game of chess on a computer screen. You can learn all the rules. The knight moves in an L shape. The bishop moves diagonally. You can write equations or algorithms to predict where the pieces will go. But you have absolutely no idea what the computer's hardware is made of. Is it silicon? Is it gears and cogs? Is it quantum qubits? The rules of the game tell you nothing about the intrinsic nature of the machine itself. When we ask, why does the apple fall? An answer, because mass bends space-time. We are answering a question about structure. We are answering a question about the chess pieces moving. Both the question and the answer exist in the same category, external measurable mechanics. But consciousness is the one exception in the entire cosmos. Consciousness is the one and only time we get to peek behind the equations. We are made of matter. We are made of atoms, electrons, and quarks, but we don't just experience our matter from the outside as a set of moving parts. We experience it from the inside. We don't just process the wavelength of light. We suffer the beauty of a sunset. We don't just process acoustic vibrations. We weep at a symphony. We don't just process structural damage to our tissue, we feel pain. So when the philosopher demands more from the neuroscientist than they do from the physicist, it's not necessarily a double standard. It's a recognition of a category jump. Physics is allowed to have brute facts because physics is just a shadow play. It's just a description of the outside of things. But when science tries to explain consciousness, it is trying to use the language of the outside to explain the reality of the inside. And we intuitively know that saying neurons fire leaves out the most vital part of the universe, what it feels like to exist. But what if we could reconcile this? What if we could close the gap? If you take this tension seriously, it leads you to a radical, almost poetic conclusion, one that is currently gaining serious ground in modern philosophy. It's called Panpsychism, or its cousin, a philosophically related idea of Panpsychism. The subtle difference between them is not important for today's discussion. Basically, it says, let's cure the double standard. If physicists are allowed to have fundamental, unexplained brute facts like mass, charge, and spacetime, let's make consciousness a fundamental property of the universe, too. Instead of driving ourselves crazy trying to figure out how dead, unconscious atoms magically generate a mind when you arrange them into a brain, what if we assume that experience is just baked into the fabric of reality from the very beginning? What if an electron not only has mass and charge, but also possesses a microscopic foundational sliver of quote-unquote experience? Not human thought. An electron is not anxious about its taxes, and a quark is not falling in love. But what if they possess some raw primordial spark of being? In this view, the universe is not a dead machine that accidentally woke up on a rock orbiting a yellow star. The universe has an inside everywhere. Gravity is the universe pulling. Light is the universe traveling, and consciousness is the universe feeling. When evolution arranged 86 billion neurons into the magnificent architecture of the human brain, it did not create consciousness out of nowhere, like magic. It simply concentrated the latent consciousness of the cosmos into a blazing, brilliant focal point. It organized the static into a symphony. So, how many whys can we pursue? Maybe there is a limit. Maybe, whether we are looking out at the bending of space-time or looking inward at the redness of an apple, we eventually arrive at the same silent, beautiful bedrock. The universe is, and it experiences. As a physicist, I spend my life measuring the shadow play. I track the falling apple. I calculate the orbital mechanics. I write the equations, but when I step out of the lab and I stand under the night sky, I don't just see data. I feel a profound, unspeakable awe at the sheer scale of it all. And perhaps that awe is not a glitch in the biological machine. Perhaps that awe is what the math feels like from the inside. Thank you for listening. If this broke your brain a little bit, good. That means the neurons are firing. Keep asking why. I'll catch you next time.